Okay, so now we already learned how to add up sums of an arithmetic sequence. So now let's look at how to do the same thing for a geometric sequence. Okay, so let's refresh our memory. What's a geometric sequence again? So a geometric sequence is a list of numbers where each term is found by multiplying the previous term by the same value, which we called as common ratio. For example, let's say we have a sequence like 2, comma 4, comma 8, comma 16. So here each term is multiplied by common ratio which is 2 to get the next one. So 2 multiplied by 2 a 4, 4 multiplied by 2 a 8, 8 multiplied by 2 is 16. So this is a geometric sequence with common ratio is equals to 2. Okay, so what is the formula for sum of first n terms in a geometric series? So if you want to find the sum of first n terms of a geometric sequence, you can use this formula over here. So in this formula, S sub n represents the sum of the first n terms and a sub 1 represents the first term of this geometric sequence, and r represents the common ratio, and n represents the number of terms. So here this is something you have to remember, and this is very important. So this formula works only for r which is not equals to 1. So because you cannot divide anything by 0, then it's going to be undefined. If r becomes 1, you see here you'll have a denominator with a 0. So in summary, what you have to do is for any geometric sequence with r not equals to 1, then the sum will be given by this formula. Okay, so now let's try some examples. Okay, so in this example, you have to find the sum of first 17 terms of a geometric sequence with the first term 1 and common ratio is 2. So you have a geometric sequence. The first term is given by 1 and the common ratio is given by 2. So you have to add the sum of first 17 terms. So in this example, n is 17. So you want to get the sum of 17 terms, the first 17 terms. The formula is a1 times 1 minus r to the power n, 1 minus r. Okay, so let's do the substitution. So a1 is equals to 1. 1 minus r represents 2. N is going to be 17 over 1 minus 2. Okay, so now if you use your calculator, you'll end up here 131,071. So if you add first 17 term of this geometric sequence, you'll end up with 131,071. Next example. So you have to find the sum of first 7 terms of the geometric series, geometric sequence 5, 15, 45. Okay, so in this geometric series, the first term is 5 and the common ratio is it's a 3, and n, that means we are looking at the sum of first 7 terms. So let's use the formula. Sn is going to be a1 1 minus r to the power n, 1 minus r. So this is the formula. So the first term is 5, 1 minus r is 3 to the power 7, 1 minus 3. So this is, if you use your calculator, this is equals to 5465. So this is the sum of first 7 terms. Okay, so now let's talk about one of the coolest ideas in math, which is about sum of an infinite geometric series. So far we know how to add sum of, that means how we know how to get the sum of finite sum, like when we have like finite number of terms we can add in a geometric series. But what if we have an infinite series with lot of terms? So in that case, how to get the sum? So infinite geometric series means it's again a geometric but with infinite number of terms. So you might wonder, so how can you add up infinitely many terms and get a finite result? Well, in some cases you can have that. So to get that, the formula is this. But uh, actually, in order to use this formula, you have to have a common ratio, which is the absolute value of that common ratio should be less than 1. In that case, the infinite geometric series has a finite sum, and we can use this formula to get that sum. So here S represents the sum of the infinite series, A1 represents the first term, R represents the common ratio. But remember, in order to use this formula, your common ratio, the absolute value of the common ratio should be less than 1. Okay, so what if the absolute value is greater than or equals to 1? Then the series does not have a finite sum. So the terms doesn't get smaller enough if the R is greater than 1. They either stay the same or grow. So the sum keeps increasing forever. Okay, so let's try an example. Okay, so here in this example, you're asked to find the sum represented by the series of this. So here you have a series. Let me write this: 36 plus 6 plus 1, and it seems like it's going forever. Okay, first of all, you have to, once you examine these three terms, you have to see that this is a geometric series. It's because there is a common ratio. The common ratio for this problem is it's 1/6. It's because if you multiply 36 by 1/6, you'll get 6. If you multiply 6 by 1/6, you'll get 1. And to get the next term, you have to multiply 1 by 1/6. So if you keep getting these numbers, you'll end up with an infinite series. You have infinite number of terms, and then you're asked to add all those infinite series. You can use this formula. It's because the R, the absolute value of R, is less than 1. So you can use the formula A1 over 1 minus R. This is the formula. So let's use this formula. The first term is 36, and in the denominator, R is going to be 1/6. And if you do the simplification, in the bottom, 1 minus 1 over 6, it's going to be 5 over 6. So this is a 36 divided by 5 over 6, which means 36 multiplied by 6 over 5. So here, if you do the simplification, you'll end up at 43.2. So if you add all these infinite number of terms, you'll end up at 43.2. So this is how you do a calculation with infinite geometric series. But remember, in order to use this formula, you should have a common ratio which is less than 1. In that case only you can use this formula. But if the ratio, common ratio, is greater than or equals to 1, the series will diverge. There's no sum.